Good Monday morning! I'm MPJ, and this is FunFunFunction. Today's episode is going to be a little bit different because I have gotten this. This thing is a particle internet button. There's really no way that I will be sitting around doing a video about something else when I have a new toy. This is not a sponsored video, by the way. This thing is just cool. So, what is it? Let me just put you on a tripod. Particle doesn't, their main business isn't making these buttons. It's actually making this thing that is inside the button. Focus! They make these tiny, super cheap computers. I think they're like 20 bucks, this thing. And it has a Wi-Fi chip and a basic processor, and it's compatible with Arduino-like devices. It's fitted onto this button, which has a four-way clicky button and multicolor LEDs around this thing. So today I'm going to hack away with this thing. I will try to make an attempt to produce an interesting video of me doing it. We'll see how well that goes. Never done something like that before. What I'm gonna make with this button is a Pomodoro timer. If you don't know what the Pomodoro technique is, it's a method of working where you work for 25 minutes, completely interrupted. You turn off your cell phone and you don't check email. You just work on one thing for 25 minutes, and after your alarm rings, you take a 5-minute break and you do things like check email or go grab a cup of coffee or just look out the window. You also track your progress a lot, so you check that, oh, I now completed a successful Pomodoro, or if you got interrupted by, say, a colleague that came over and asked you something, or you interrupted yourself and got that coffee anyway during the Pomodoro, that Pomodoro is void and you put a little interruption check mark, so you keep track of your progress. It's one of the few productivity techniques that, actually works for me. Either way, let's get started. For a channel that is named FunFunFunction and is about programming, I know I do an awful lot of talking, and a lot of people they complain about that. They say that, oh, I miss when you were doing coding, but the thing is that in my experience, coding is a really small part of the success of a software development project. It's important, but it's just a tiny part. Software development step 1, steal Sharpie from girlfriend. Alright. By the way, this is this week's board game tip, Pandemic Legacy. Okay, I haven't played it yet, but it seems awesome! So, the Photon, it has a bunch of multicolor LEDs. It has these 4 buttons. When, say, this button is pressed, I want this to start lighting up like a clock until it reaches 25 minutes. There's a lot more features that I would like to have on this thing. If you have seen the Martian, you know that being an engineer is about solving one tiny problem at a time. The Photon, it runs a C. I think it's a C dialect. I'm not sure if it's actual C, but either way, it's in a language that nobody really wants to program, at least not me. So what we're gonna do is we're gonna have a Node.js server that controls this thing. So the internet button will basically just be a dumb terminal. It won't know anything about Pomodoros. It will simply send, like when I press this button, it will just send an event to the Node.js server, and it will subscribe to events from the Node.js server, such as light up, LED 1, at some color or stuff. So before we do anything else, this event thingamabob, that is what we are going to set up. I'm trying way too many new things at once today, but that's the charm of it. Let's do it. Okay, first we are going to create a project. What are we gonna call this? So whenever I do project, I spend way too much time on picking names. So what I do
is that I go to the list of Intel code names on Wikipedia and I pick one at random whenever I do a new project. So, Crow Point. Okay, no, that sucks. Gross. What again? Right. Knoll Creek. Kyrene. That's a codename for our project. Let's close this. We're gonna do an npm init. Kyrene 111 description. Leave that empty. Index.js works for me. Hahaha, no. No! Keyboard out of batteries! Keyboard, the Xbox controller will suffer for your sake. Let's set up a GitHub repository. Kyrene. This is gonna be a Node project. And let's do an MIT license. Copy that out of there. Keywords, no. Author, I like writing my name. Yes. Set it to Git. Git remote add mpj monk git pull rebase mpj master. Oh, sorry. Dash rebase. Cool. Git add the package.json. Commit package.json. Yeah, and git push. Git push mpj master. I stress that this is not a tutorial, this is just you watching me code, really. Wow, we have a Git repository and a package.json. That calls for celebration. We should get some coffee.
Coffee in Swedish. Caffeinated.
I'm using Express and I'm gonna use Express. Let's install that. And install save Express. So using the save flag here will actually automatically add the dependency to your package.json. I'm gonna create the web server index.js. Tutorials are nice and all, but I don't do them because they grow stale like in no time at all. This is just me doing something that might inspire you to make something of your own. How does Express work? Copy-paste programming. We're now running, okay. Much later, I'm out of coffee, but we've made some progress. This is now a working Node server. I'm just gonna run it and show you what it does. And run index.js, example app listening on port 3000 there. And we're gonna switch to another terminal window if I remember how to do that there. So we're just gonna do a curl where we send some JSON here. We post it and we're here like hello world. And we're posting it to localhost 3000 event and enter. Okay, it doesn't give any response, but it like sends out here body world. And that is because we have this over here, and it will parse it as JSON, and it will echo out the hello part of the JSON here. I want to deploy this on the internet so that I can call it from the internet button next. I'm gonna do that using Docker on the Google Cloud Container Engine because I feel like it. Whoops, my battery ran out of juice. If you don't know what Docker is, it's sort of it's a way of packaging your applications into small Linux containers, and it's really nice because it allows you to run basically a little Linux cluster on your computer and have and try your apps out in an environment that looks very much the same as the one on the server, because you will be deploying this little Linux container with all of its dependencies, and it will always be the same thing locally and on the server. So Dockerizing a Node app is really easy. This is the Docker file here. Dockerizing a Node app is super easy. I have a file here, the Docker file. This is the only file that we need to do this. What the Docker file describes is dependencies. In this case, the only thing that we need on the Linux container is Node. And Node provides an official Docker image actually for you. So all we need to do to get Node into our Docker container is just this, from Node 550, and I've added slim because I want it to be small. Next up is here, we want to create the app directory. What we do is that remember that this is on a virtual Linux machine, so it will create a directory here. And then it will switch the work directory to that directory. It will then take our package.json from our application and copy it to that directory on the Linux machine, and it will then run npm install. After that, it will copy the rest of the app into the app directory on the server. It will expose the port 3000 so that we can access it from outside the Linux container, because by default nothing is exposed for security reasons. And then it just runs npm start, and npm start is, by the way, I've defined that in the package.json here as basically just Node running the index.js in the working directory. Now, how do we use this? Well, first of all, we have to start the Docker terminal. After you installed Docker, it will create this thing for you, the Docker quick start terminal, and it will run and it will look like this. And then you just, since we are in the directory that has the Docker file, we just go docker build. Docker build this directory. And this will take some time the first time, but I have all this stuff cached. And it will build an image for us. It doesn't run it yet. We have to do that too. So we're gonna do docker run.t for terminal so that we see what's going on. And we paste in the image name, and it, boom, runs. So now we see that, okay, it's running on port 3000. Okay, let's try that curl thing again. All right, this will fail to connect because we are no longer on our local computer anymore. Like, the server is running on this little Linux cluster, and that Linux cluster has assigned it an IP on our local machine. So we need to check out Kitematic here, which is an application that comes with Docker. And it's going to show us that the Linux container has been given this IP here. And like we see here that 3000 is exposed from the inside, but it's not actually connected on the surface. We need to add 3000 here as well, and then hit save here. Now we can take this IP here and paste this in here, and this should now work. Maybe. Yes, it looks like it does actually. All right, let's see if we're not attached to this Docker container. So we need to see what Docker containers are running. Okay, we have this container right here that is running. I'm gonna copy that, and I am going to write docker logs, and it works. Next up, I want to deploy this thing on Google Cloud. First of all, we need a little cluster on Google Cloud. We need some servers. We do gcloud container clusters create Kyrene, our project name, and then we specify our machine type, G1 small, and hit enter. Whoopsie, it wants a zone as well. we have to do G cloud compute zones list. Oh, I haven't set that up in my project yet. Let's see, I will have to go into my cloud console and we're gonna go to the API. Oops, go to the API manager and compute engine API, and we click enable API here. And now we can call gcloud compute zones list. No! Oh, it's still enabling. That prompts me to get some lunch.
Wow, that's sun. Okay, we're going to a very fancy place for lunch. While I'm walking there, I want to talk about some things. I mentioned earlier that I think that development is not all that much about coding, really. It's much more about just having this attitude of, figuring things out. Getting into this mode of just solving one problem after the other. Sometimes that is coding related, but sometimes it's just related to figuring out, just doing research on what tool is appropriate. Perhaps you need to formulate your problem a bit clearer in order to understand it. Sometimes you just get stuck. Your brain does not process information, so you need to just go play ping pong or figure out some way of getting yourself unstuck. Sometimes the problem is that your colleagues don't understand how something works and your relationship with them doesn't function. Often it's just fiddling around with weird configuration files. But what it all comes down to is having this process for problem solving. And I think that the most important thing that you can do to become better as an engineer and as a creative professional is to, cultivate your own creative process. I started thinking about this a lot ever since I watched The Martian, which is a movie and, more importantly, a book that you really should read if you have any kind of creative profession. Without spoiling it too much, I think that The Martian is basically a book about being a creative professional, but it's set in a Mars survival setting. The core of engineering is that you are stuck with this huge problem. In this case, you're stuck on Mars alone. And how to deal with that? How to eat an elephant that big? And of course the answer is one piece at a time. You break one tiny bit of the problem off, you solve that, and then you break another part of the problem off and you solve that. So anyway, this is not a tutorial video then. I think I kind of have some problem with tutorials. They're fine. I watch tutorials. They're handy to get a sense of how something works. But tutorials also give you this idea that development is more neat than it really is. I mean, development is essentially being stuck on Mars with the environment trying to kill you. Well, it's not really that, but it's kind of like a mild variant of that. Like, the universe isn't an ordered thing, and development isn't an ordered thing. It is up to you, the developer, to make it an ordered thing. That's your job. That is what it means to do development. And I think that this is the core of being a good creative professional or an engineer, that you construct a very clear image of where you want to go, and then you look at what the problem looks like, what is preventing you from getting there, and then you break a tiny bit away from that problem and you deal with that. And that gets you a bit on the way, and then you break off another part and deal with that, and so on. Maybe hundreds of thousands of times until you solve this big ass problem. And that's what I think it means to be an engineer. Oh, by the way, this is the fancy restaurant where we are going for lunch. Meatball. Hey, and
En stor köttbulle med mos, tack.
Yes.
Nom, 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 nom. Yum. Oh, we're back from lunch. Let's see if the Google API has updated. Yes, it has. Okay, the API is enabled, but you can't use it in your project until you create credentials. Okay, I didn't need to do that to do this. Either way, region, Europe West 1C, that sounds good. Zone. Oh, maybe it's the Google Container Engine API that I need to. Okay, let's try that. Oh, this worked! Oh! So Google Cloud is now spinning up a Linux cluster for me, which is pretty cool. It is done. Okay, so we have a little cluster running in Europe on G1 small machine type. So what we want to do now is to build our Docker container or Docker image with a special tag. So it looks like this. So we're gonna do a Docker build, just like we did before, but we are going to build it with this tag. So we're gonna do it with the this Google Cloud Container Repository. And we are going to use my project name. This is my project name on Google Cloud. And then we're gonna have a name for the container, and we're gonna have a version tag here. I'm just gonna start with 1, but this could be any string. I mean, on many projects, I tend to use a git hash here. And finally, we have the dot, which means that we want to build the Docker file in the current directory. Oh, and I'm doing this in the wrong terminal. We need to do this in the Docker terminal, which I think is this one. Right, and we have now successfully built this container. That's nice. So now we want to push this image that we just built up to the Google Cloud Container Repository. And we do this by calling gcloud docker push and paste in the image that we just created. And it will push it up, hopefully, in a while. Fiddlesticks! Okay, found the problem after like half an hour. It turns out that I thought that my project ID was this, but that's just my project name. My project ID is here. So I need this one. So we need to rebuild the image. Bam! And now we should push this to the Docker Cloud Registry, and it's... Come on! Oh, yes! It's pushing! Pushed! So now it's time to get our cluster running this image. And to do that, we need to use Kubernetes, which is Google's system for managing clouds of Docker containers. And to do this, we need to create a replication controller, a Kubernetes replication controller. And a replication controller is a thing in your cluster that controls pods, and pods are basically your virtual servers. So let's say that a pod goes down. It is the job of the replication controller to monitor that and bring that back up. The replication controller also keeps tabs on how many servers you need, and the replication controller is also responsible for load balancing and stuffs. Either way, we're going to start a replication controller, and you do that by defining a Kubernetes.json, which we have here and here. Down here is our Docker image. This is the same as the Docker image that we just built, and this defines that the pods are going to be using that image. We're exposing port 3000 here, and we don't really need this. And now to create our replication controller, we simply run, this is complicated stuff, create.f kubernetes.json, and bam, we have now a replication controller going. And I can just go view Kubernetes control, get rc to see that, okay, we have a Kubernetes container, and while we were talking, it had the Kubernetes controller. The replication controller will have created a pod, right? But we have an error. So let's see what's up. kubectl describe. kubectl describe pod. Oh, right. Because we're doing the same mistake as before. We need this. We're not doing it right. Okay, cool. So what I'm gonna do now, since I created the replication controller wrong, I'm going to kubectl get replication controller. I'm gonna pick this one. I'm gonna go kubectl delete replication controller create, deleted, and let's do this again now that we have a correct kubernetes.json with this thing correct here. Oh, I can't find it in my history. Let's do it again. kubectl create file kubernetes.json, and now it's created. kubectl rc, cool, and we're gonna go kubectl get po, and it's running good. Now I can actually read the logs from this, and I can go Kubernetes controller logs. Oh, looky! So now we have a node server running in the Google Cloud. So our node server is running, but it's not exposed to the internet yet. And to do that, we need to grab the replication controller. So kubectl get rc, the replication controller here. I'm gonna copy that, and we are going to run kubectl expose replication controller and paste that in, and we're gonna assign it as a load balancer. Bam, service carrying kube blah 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 exposed. Let's see what it exposed, because it's now creating a services. Cool. So it's haven't assigned the external IP yet, and while it does that, I'm gonna explain what just happened. Pods in Kubernetes they're ephemeral, right? They will die for various reasons. Perhaps that Google pulls the service out of their racks in the space, in the data center, and the replication controller will recreate them. So they are ephemeral, right? They have new IPs all the time and they move around. But you don't want end users to know about that. So you want to expose an IP like that is permanent and that is not tied to the pods. You want to have something that just takes that IP and redirects it to whatever pod is available. And that is what services are. We've just spun up here that it has this. Check again. All right. So now it's gotten this external IP address, and whenever that is accessed, that will be redirected to a pod with the label service name Kyrene, and this is what the labels that are in the Kubernetes.json file are for, so that stuff like services can find the pods even though they have different IPs and names all the time. This should be available. So now I just copy paste this. Let's see. We're gonna do this thing with the JSON post again, but I'm going to paste the external IP. Cool. And now, hope for the best. Enter. Okay, cool. Right? We never send any response, so that is why nothing is happening. But let's check the logs now of that pod. Again, kubectl get pods. Right, that's our pod. It's still running. It hasn't crashed. That's good. So it's kubectl get logs. No, not get logs, just logs. And we paste in the pod and body world. You know what? That's it for today. We didn't get a button working really, but at least we gotta have a new Node server running in the cloud. So that's some progress. You saw one little bit at a time. You might not always get a lot of progress every time. This was a weird episode. I know it was a weird episode, but I felt like experimenting a bit. Perhaps we learned something. At least I did. I am MPJ. This is FunFunFunction. Until next Monday morning, stay curious.